are parallel lines and transversals, okay? So 70, this angle degree here, 70, and angle C, these angles are vertical. So therefore, angle C is 70 degrees. Now I also notice that angles, the C and angle B, I have a linear pair here. They form a line. Okay, angle B plus angle C is a linear pair. They form a line and therefore add to 180 degrees. So I can find the measure of angle B by doing 180 minus 70, and I'll get 110. And because I already know that vertical angles are congruent, angle A is also 110. Now, we haven't talked about triangles yet, but I'm hoping you might remember that you learned in middle school that a triangle is also, all three angles add to 180. And I notice here that these little arcs tell me that these two angles are congruent. So I already know that 180 minus 70 is 110. So that means I'm going to split this 110 degrees in between these two angles. So if I do 110 divided by 2, and I can divide by 2 because they're both congruent, I get 55 degrees. So that means both of these angles are 55 degrees. Okay. Now, with that information, I can determine the measure of all the remaining angles, because everything, all the remaining angles, either form a line and add to 180, or they are vertical and therefore congruent. So angle E is going to be 55 degrees because it's vertical. And then to find D and N, I need to do 180 minus 55. So I get 5, I get 2, I get 125. Okay. And because this angle over here is also 55, my angles are going to be the exact same measure, because there's only 180 degrees to go around, and vertical angles are always congruent. Now, from our previous video, we learned that parallel lines, when parallel lines are, and that's what this symbol is, those two little lines in between P, Q, and R, that means parallel. Okay, so when the lines are parallel and they're cut by the same transversal, which is this diagonal line here, this is called a transversal. Okay. Essentially what we're doing is it cuts the transversal as the exact same angle. So therefore, what I'm doing is simply doing, think of it as a copy and a paste. I'm literally going to copy my angles here and paste them here and here because the lines are parallel. Essentially, I'm just repeating P, Q, and R over again. Q, and R are copies of line P. So that means angle F is 125, and angle L is 125, M is 55, and G is 55. So obvious, and again, R is also parallel. So this is 125, this is 55, 125, 55. When the lines are parallel, we are literally just taking the angles that are on one parallel line and copying and pasting them into the remaining angles. Now you'll notice that this set down here, this line is not parallel. And actually this says it's 80 degrees. So it's not going to have the same measurements as P, Q, and R. So angle S, because S is vertical to 80, that's going to be 80. And if I do 180 minus 80, minus 80, because again, we have a line, 180 minus 80 is 100. So angle U is 100 and angle T is 100. To our numbers, you'll notice F and J, M and I, those pairs have the same angle measure. You'll notice G and K, L and H, those are also the same angle measure. At R. So that's these two angles and these two angles. And you notice those aren't congruent, but 125 and 55 do add to 180. So with our numbers, you'll see that the corresponding angles are always congruent. Now there is a special relationship between these angles formed by these parallel lines. Okay, so we're looking at, specifically, we're looking at lines Q and R. So this is Q and this is R. And there are four new angle types that you need to learn. The first are called alternate exterior. Okay. Now, the alternate, the first name tells us where on the transversal. Remember, this line here is the transversal. Tells us where on the transversal the angles sit. So alternate means opposite. Okay. And exterior means outside the parallel lines. Okay. So where the first word refers to the position of the angle on the transversal, the second name, the exterior, tells us where the angle's positioned on the parallel line. So I'm looking for a pair of angles, so that's two angles, that are on opposite sides of the transversal, but sit on the outside of the parallel lines. Okay, and that's going to be F and J. Those two are alternate exterior, as is M and I. Okay. Angle F and angle J, and angle M and angle I are what we call alternate exterior angles. And if we go back, so alternate exterior angles are always congruent. Next angle pair is alternate interior. So alternate being the opposite side of the transversal, but this time interior means they're inside or in between the two parallel lines. So that is G and K. Those are alternate interior. And L and H are also alternate interior. And if we look at, therefore, they are also always congruent. Okay. Third here is what we call consecutive or same side. Your book uses consecutive. I learned same side interior. Okay. So we already know they're on the inside, but consecutive meaning one right after the other or same side of the transversal tells me that L and K are same side or consecutive interior, as is G and H. Both of those angles are considered consecutive or same side interior angles. And if we are consecutive or same side interior angles are always supplementary. Okay, I'm going to slide over to this side now. Our last type of angle is called corresponding. Okay, corresponding angles refer to the position. If we look at our think of this as four corners of a street, angle P is in my upper left-hand corner of my box on line Q, lowercase q, and angle Q on line R, there are also in the upper left-hand corner of this particular intersection or this box. So P and Q are corresponding. So corresponding angles refer to the position. It's actually the same position on both the parallel line and the transversal. Okay, so if you look at angle Y, which is in the upper right hand corner of my box, that corresponds to angle W. Then I'm gonna put I need a letter here to match everybody up. So angle Z, you'll notice, is in the lower right hand corner on line Q, and then that matches to angle R, which is also lower right hand corner. And then of course angle X and angle V are also in the same corresponding position. And if we go back to our